Hi guys, in this video we discussed type 4. We have discussed type 1 up to 3. And in type 4, basically very similar to type 3, okay? But you will see the subtle difference. There is a very subtle difference here. Let me take an example, a very typical one. Sine x is equal to cos x. The difference here between this problem and the previous problem, let me quickly write this one. I think in the previous problem, we had something like sine 2x minus 10 is equal to cos x minus 15. I think so. Yeah. Here's the difference. In this case, the angles are exactly the same. In this case, the angles are different. Different angles, same angles. Literally, or another way to say this, equal angles, okay? Non-equal angles, okay? That's another way to look at it. So if you've got non-equal angles, you go the type 3 style, okay? Use a co-function reduction, okay? But you've got same angles, then come on, instead of using the long way of the co-function reduction, let's just take the short way. We use the identity. Actually, that is the way. Actually, we're gonna do the use of identities here. Okay, so that's type 4, using identities. So usually in this case we will always divide by cos, because sine over cos is tan. So then you have tan x is equal to 1. Okay, then you know x then is 45, because 45 is a special angle. So your general solution becomes 45, okay, plus k dot 360, where k is an integer, or, okay, what is your reference angle? 45, or x is 180 minus 45 plus k dot 360, where k is an integer. That's it. Of course, you gotta tidy up a little bit there, and I think that is something like 225 degrees plus k times 360, and k is an integer. So that's it. That easy? You ask me, yes. Now, sometimes they make these things tricky to just see if you guys can notice this. So I'm going to write this problem for you here. So suppose they give you 2 sine. Let me use now theta. Okay, let me go back to using theta a little bit. And then they say this is plus, okay, plus cos theta. And then they say equals to 0. So you won't see it right away that there's a type 4, or I've got to divide by cosine throughout, until you try and write this in somehow standard form. So again, gonna go ahead here and divide by cos theta, as I said, cos theta. Then I have here 2 tan theta is equal to minus 1. And then of course I've got to tidy up a little bit, and I've got this. Guess what? You have actually taken this to type 1, the most basic, simple trig equation that we have always dealt with. Okay, so remember, then the next thing that happens is to find our reference angle. Okay, our reference angle theta is 26.5. Okay, well, let me round it to nicely to 1 decimal place, 26.6 degrees. Now guys, remember, when you look for this, you're gonna say what you are pressing here, you are pressing in your calculator, something like that. So shift, tan, and that. So I'm not putting the negative here, because the negative is just telling me the quadrant that I'm dealing with. Okay, so hence this. So my solution, of course, k 360. Okay, k is an integer. Okay, so I've already explained the concept of 360, right? Now, there's the first solution. The second solution, if I want theta, I can simply then say 180. What is my reference angle? So remember, my reference angle I didn't write it like I did there. I did here. So theta is 26.6 degrees. Yeah, so that's my reference angle. So 180 minus 26.6 plus K, 360, and I'm gonna indicate that K is an integer. So I'm gonna go ahead here and do the math there. So you're gonna get 153.4 degrees, okay, plus K dot 360, and K is an integer. And really that's about it. That's the long and the short of it. You are done. You have done finding the general solution. If they said a specific solution, then they would have given you an interval to work on, like I've shown you in the previous example. So that's just about it, guys. I hope you are getting the sense of this, and you are enlightened and enjoying this. In the next video, I'm going to show you now, it's still type 4 where we use identities, but in this case, something very significant happens. We are using the square identity instead of the quotient identity. Here we used the quotient identity, okay? The quotient identity that tan theta is sine theta over cos theta, okay? Now in the next one, we're using the square identity. All right, till then, take care.